Hello everyone. To continue for our unit of complex variables, today's lesson is on planar sets. I encourage you to please try the math task because this is going to help you use your prior knowledge to connect to the new concepts that we are going to be learning. I am going to go a bit quickly through the math task for timing reasons. So in the hopes that you attempted the math task, you should have gotten a standard formula of a circle based on the image of x minus 3 squared plus y plus 2 squared equals 7 squared. And when asked to write a complex number using that formula, I hope this is what you found and recognized the reals and the imaginary. So keeping this task in mind, we're going to move forward as to how the standard formula of a circle is very similar to the modulus of complex variables. So, given the complex number that we formed, x minus 3 plus I times y plus 2 equals 7. If we were asked to solve or find a modulus, or the modulus of this function, we need to think about what we know already. And we know the modulus. We know that it's a positive square root, where x is your real and y is your imaginary, as hopefully you found and identified. We're gonna plug those values into our modulus formula. And here we want to get rid of that square root, because that is what's going to get us back to our standard formula of a circle that we began with in the math task. Hopefully you're able to recognize that in order to get rid of a square root, you square both sides. And a quick critical thinking question. What would the image of the circle look like if the function was an inequality? So the given function here is now changed to an inequality. What would the image of the circle look like? Think back to inequalities, the dashed or dotted line, and the solid lines, and how less than or equal to is represented using the dashed line, and how that would change the image of the circle that was given in our math task. So in hopes that you are recognizing some patterns, we are going to move on to the lesson with an example. Given the function z minus I less than 1. So right away, this is an inequality, and we are asked to solve for the modulus of this inequality. We're going to begin with what we know. We know z equals x plus I, and hopefully you also know the modulus formula at this point. So we're going to use substitution and plug in x plus y for z. As we have here, x plus y is going in for z. Then we are going to group the real and imaginary. And for that, we may have to factor out an I when needed. For this particular example, we have x plus I, y minus I, and I hope you recognize that we can factor out an I. And that is how we group the reals and the imaginary. And a quick thought. Can you recognize what the center will be? By looking at this step right here, can you recognize what the center will be of our image? Going to step 3, we are now going to apply the modulus formula. Recognizing our reals and imaginary and continuing to keep it as an inequality. As we did in the previous step, we're going to square both sides to get rid of that square root. And for step 4 and 5, I want to say it's very flexible on how you approach these last 2 steps. We are asked to sketch the image and describe the image. For some students, it may be easier to describe the image first or sketch the image first. Whatever works for you is completely fine. When we sketch the image on the complex plane, we have a center of 0, I, and a radius of 1. So when we describe the image, we say that the function has a center of 0, I, and radius of 1, and it's an open circle, and that's due to the less than sign. Now we have a few thoughts and questions. Can you make a connection to the given function and center? So this is our center, 0, I, and this is our given function. Can you recognize the center based on the given function? If you haven't yet, that's all right. This is why we go through the steps. And another question is, why is the circle shaded on the inside? Think back to your inequalities. Shading parabolas on the inside or the outside, or just shading above or below a line based on the sign of your inequality, greater than, less than, and so forth. We're going to keep referring to example 1 to look at the terminology and how to describe our images. So looking at the example z minus 1 less than 1, when we are looking for the modulus of z minus 1 less than 1, we derive a formula that gives us the modulus of some complex number minus a center less than e. E also represents the radius, but in this complex variable unit, we refer to the radius as the neighborhood.